So the product rule says if u and v are differentiable functions of x, then derivative with respect to x of u times v is equal to u times the derivative of v with respect to x, plus v times the derivative of u with respect to x. The short version, how I usually write it, is this way. So it says u times v prime plus v times u primed, u dv plus v du is what I end up saying a lot. And how that would work on example 12, for example. So my u in this case would have been x squared, and my v in this case would have been 3x. So then my du would be 2x, and then my dv should have been just 3. And again, I could have written this as u primed, and I could have just written this as v primed. All right. So if I have uv primed, well, that would have been just x squared times 3. And then if I had vu primed, well, that would just be 3x times 2x. So equaling these all out, I should get 3x squared here, and I should get 6x squared here once I multiply that out. So adding these two together, uv primed plus vu primed, which is now just going to be 3x squared plus 6x squared. Hey, now I get that 9x squared. Fancy how that works. Alright, but let's move on. Okay, so let's do another one just because, not everything's nice and pretty and easy. So let's remember some exponent rules. So it says find dy of dx if the y is 3 plus 2 times the square root of x times the quantity of 5x cubed minus 7. And we need to try to do this first without product rule and then with product rule, so fun times. Distributing this out again. First, I would have y should be equal to 15 x cubed minus 21 plus 10 x so I've got x to 7 halves. Alright, and I would finally have minus 14x to the 1/2. Because again, square roots are just the 1/2 power, which is going to be a fun time here in a second. So then y primed is actually going to be 45x. The negative 21 is going to go away. Plus 10 times 7 should be 70 divided by 2. X subtract 1, so I should get 5 halves. Minus 14 times 1/2 should be now 7. And then x now to the 1/2, subtracting 1. So all in all, this should just change to what, 35? Okay. The only thing I need to clean up is I don't like negative exponents. And if I started with radicals, I should probably end with radicals. So I should get y primed is equal to 45x plus 35x to the inner over outer minus 7. And then x is going to flip to the bottom because that's the only thing attached to that negative exponent. So I've got x to the inner over outer power. And then I should be done with that. Okay, that was without product rule. Not so fun. Alright, now with product rule, I'm going to take the derivative of both pieces. So I am saying, okay, well, u is going to equal 3 plus 2 times the square root of x. And I've got v, which is equal to that 5x cubed minus 7. Alright, so now I've just got to find u primed and v primed, so that way I can plug it into this lovely little uv primed plus vu primed is equal to some nonsense. So I'm just going to rewrite this as a fractional exponent because it makes it easier in my brain. So this is actually 2 times x to the 1/2. So if I take the derivative of this, this is actually going to be 2 times 1/2 times x to the negative 1/2. So then all in all, this is just going to become x to the negative 1/2 or 1 over the square root of x, depending on how you want to write that. I'm going to leave it as x to the negative 1/2. And I'm actually going to end up probably using this part here in a second instead of that square root blah here in a minute. But we'll get to there. And then we've got 15x squared over here for v primed, and then that's it because that 7 drops off because it's a constant. Alright, so now I've just got to find this bit. So I've got u, which is 3 plus 2x to the 1/2 times v primed, which is 15x squared, plus v, which was 5x cubed minus 7, times u primed, which is x to the negative 1/2. Cool. So now all we got to do is distribute. So in the first piece, I would get 45x squared plus, what is that, 30x, no, it should be x to the 5 halves. 5 fifths would just be 1, because you'd have to keep your base, multiply your not multiply your exponents, add your exponents, sorry. And then over here, I should get 5x, again, add your exponents, so I should get 5 halves over here as well, minus 7x to the negative 1/2. Yeah, and then I can combine my like terms. Just checking over those exponents. I've got 45x squared plus 35x to the positive 5 halves minus 7 over, I guess I'm not going to change that to being over yet because I haven't changed any of the other exponents, x to the negative 1/2. And again, if I started with square roots, I should probably end with square roots. So I should get 45x squared plus 35x, inner would be 5, outer would be squared, minus 7 over inner for outer, and then I would be done. Honestly, check to make sure they match. So the thing that I see here is that my 45x squared, my 45x doesn't match. That means that I messed up one of them. And looking back, I had 15x cubed, which means that, hey, I should have multiplied that exponent, which I did, but then I should have subtracted 1 off my exponent, not 2. So even I make mistakes sometimes. It's a nice way to check your work if you do it both ways. Other than that, you guys are going to end up having a preference. Honestly, sometimes it's going to be easier to do it this way with this product rule that we're just now learning. And sometimes it's going to be easier just to multiply it out and roll with it. I can't say on this problem I prefer one or the other because they're both gross. But there's going to be some times when you are going to be like, oh, I should just multiply this out and call it a day. Like, it's easy peasy. But then other times it's, oh, product rule looks a heck of a lot better. And you'll see what I mean when I start working with it. Alright, in my next video, I'm going to talk about quotient rules, so I'll see you over there.